So in question 3, we have a small block of mass m0 attached to the end of a spring constant k0, which is attached to a rod on a horizontal table. We're told the rod can rotate at various speeds about its axis. And we're told when the rod is not rotating, the spring is stretched to a distance L. At time t1, the rod is spinning such that the block moves in a circular path with a constant tangential speed v1, and the spring is stretched by a distance d1. And we're told at time t2, the rod is spinning such that the block moves in a circular path with a constant tangential speed v2, and the spring is stretched a distance d2 from the spring's unstretched length. We're told d2 is larger than d1. And in part 1, we need to represent on the following dots the forces that are exerted on the block by the springs at time t1 and time t2. The spring force must be represented by a distinct arrow starting on and pointing away from the dot. We also need to be careful with the magnitudes of the forces. So what we see is that in D2, in the second case, we have a larger extension, and a larger extension corresponds to a larger spring force. So the arrow for time t2 will have to be longer than for t1, as we have a larger spring force, larger displacement. And then we need to, in part 2, referencing d1 and d2, describe the reasoning for drawing the arrows as we did. So we kind of already saw that. So we can say at t2, it's longer because the spring force is related to the stretched length, and therefore, since d2 is larger than d1, we know F is equal to k times x, and therefore it will have a larger force. And then in part 3, we need to determine whether the tangential speed of v1 or v2 is larger, and we need to justify our reasoning. And well, what we can say is that the net force is equal to the spring force. We only have the spring force acting on the block. And what we know is that when the spring is stretched by a longer distance, so d2, the net force then will be larger. And what we know is that the net force is related to the speed, which we will see through the centripetal motion related to speed. And therefore, a larger net force will mean a larger speed, and therefore the second speed will be larger.